Cut that out. Cut it out. Come here. Come here. It's okay. Cut it out. Cut it out. You've been quiet all this time. Now that I started streaming, you want to start warming up your vocal cords? Hey. There's nobody there. See? There's nobody there. Hey. You're just waking up from your nap. You hear somebody making noise out there, disturbing the peace. Shoot, is that thing frozen again? It totally is frozen. God. All right, so I did not know it was frozen. Something said it's taking a long time. It's been at that time for a long time. Let me get started there. Yeah, like my equipment is like totally shutting down. Did not know it was frozen. Okay, let me try something real quick. Hopefully it don't mess my stuff up. What if I do it like this? Okay, like this. I'm gonna relaunch that. All right. Well, we're gonna go with it. Hopefully, everything kind of progresses properly. So I'm sitting up here watching my clock, and I don't know. It's weird. My laptop's behaving weird. Anyway, let me get it down a little bit lower. I didn't want it on mute though. I'm gonna leave it like that. So I guess I need another clock. Maybe I'm putting too much on my laptop. Okay. So let me see if there are any announcements. So this is week 5. Okay. I think I'm not really sure. Let's see. Other than, I mean, the main thing is just log in right now, like you're doing. So I need a clock because that thing is totally throwing me off now. The main thing is that you're just log in to get your attendance credit. Okay, each session, get whatever questions you have, get them answered. We can actually class time is actually like it's supposed to be. My intent was for it to be a study session. So like if you wanted to ask questions, someone was like, kind of go through the homework. But if you have questions over anything, like class time is the ideal time to get those questions answered. We're here, and this is really just Q&A session. So if there aren't questions, what I'm going to do, I'm just going to kind of continue doing what I normally do. So I'm going to hop over to Pearson. Hopefully the music's not too loud. And just kind of keep going where we left off. So we're still working in section 1.5, transformations of functions. There are, let's see, 2, 4, 6. I think there's like 8. There's a lot of transformations. I think it's like at least 8 of them. And I'm just gonna kind of keep just stating them as they pop up. I go in like a progressive order or a sequential order during the pre-recorded lecture. My recommendation is to watch the lectures, take notes as if you're in class, and then write down your questions, and you ask your questions during class. And then that way, by the time I do, and you want to do this stuff in advance, so that way, by the time I start working on the homework, it's supposed, the idea is for it to be reviewed. All of this stuff is available. I'm just kind of going step by step. The only things that's not available are the exams. All right, I think even the quizzes might be available. Okay, and I am monitoring the chat, and so feel free to either, oh, can you guys hear me? Hello. Okay, that looks good. Yeah. Let me check one other source, make sure that one's working. Ali Oxenfree, that looks good. Okay, yeah. So let's keep going. So yeah, I am monitoring the chat, and feel free to unmute yourself if you have questions. Again, my expectations are that you guys check in at each class. Okay, just check in, get into the Zoom. Once you get into the Zoom, you've gotten your attendance credit. You don't have to stay, but I need you to check in each day. Like, you don't have to stay, but definitely at least check in so that we can at least touch bases. I don't want to go extended periods of time without connecting with you guys. Right? That's not a good look. Okay, so again, like I was saying, if there aren't burning questions, what I'm going to do is just kind of keep making my way through the homework. Okay, and I'm just here to answer questions. So feel free to chime in, unmute, type in the chat. This is the best time to get questions answered. Get your questions answered. Write the functions. The function whose graph is the graph of this was shifted to the right by 1 unit, right? So I think last time we said that vertical manipulations outside manipulations are typically vertical manipulations, and inside manipulations are horizontal. So if we want to move it to the right, we need to do an inside manipulation. So we need to change this on the inside. So intuitively, you might think, oh, well, let me say +1 on the inside, but the inside is actually kind of the reverse of your intuition. So instead of saying +1 on the inside, we're actually going to do -1, all right? Quantity squared, right? So this should be it. They might want us to expand. Simplify your answer. Let me try this. If it marks it wrong, then I'll expand it. Okay, yeah, that was it. So we just moved it to the right by 1, right? So if we say -1 on the inside manipulations are horizontal, and the inside typically is the reverse of your intuition. So even though we went in a positive x direction, you actually say -1 in order to elicit that change, okay? And again, I go into more details on why that stuff is in my pre-recorded lectures. Write an equation of a function that has the graph of the given characteristics. It has the shape of a parabola, but it's upside down, shifted right by 8 units and up 2 units, okay? So we have a U-shaped graph. When we flip it top to bottom, that means we're multiplying by a negative. It's like our y's are going from positive y to negative y. So that means there should be a negative on the outside of our function, right? So it can still be any of these. And then it says shifted to the right by 8. So if we're going right by 8, that means we need a -8 so on the inside. So it has to be either A or D, okay? And then we said up 2 units, so then it has to be D, all right? So this one says if we work our way from the inside out, this says go right 8, flip vertically, and then go up by 2. Inside manipulations go side to side. Outside manipulations go up and down, okay? All right. So it seems like we'll get through these rather quickly. I guess I can work on this week's quiz too. Let's see. Write an equation for a function whose graph is description. It says the graph of this is shifted 6 units to the left. Okay, so let me see. I'm going to start with I'm going to do parentheses x cubed, or x to the power of 3, okay? So now, that's the basic function. It says stretch vertically by a factor of 4. So vertical manipulations, again, we need to be outside our basic function. And it follows our intuition, so we need to multiply by 4. It says reflected in the y, so that's reflected side to side, so the negative needs to be inside, like that. And then shifted 3 units up, so we need a +3 out here, right? If we cube a negative function, the result is negative. So what I'm going to do is write it like this. Okay. This should. Yeah, this should do everything we needed to do. Let's think about it. Let me try one more time. shifted 6 units. I missed that 6 units to the left. Okay, let's go back. I missed that part right here. Like this, like, nope. Like this, we had a negative here. Now, if we're going left 6 units, that's the negative x direction. So we need to say plus 6. So let me see, plus 6. Now we could just leave it like this. Let me see. I definitely missed the 6 units to the left last time. So we started with the basic function. The plus 6 moves it to the left. Let me think about it. Okay, let me do it. There's one other thing that's a little bit trippy here. Because normally, without that negative, it would be like this, right? But then when we flip it side to side, I'm just trying to capture that negative properly. I'm tempted to distribute a negative, but I'm gonna go back to something like this. And before I submit it, what I'm gonna do, I'm gonna see how they did their result. I'm gonna view an example, right? And let me see, left, reflected. So it has the 2 features that I'm a little bit stuck on. So I'm gonna go down and see how did they capture theirs here. Yeah, that's what I was thinking. And that's what we have. So they see how they have negative x plus 7. We got negative x plus 6. You know, so we can switch it around. I think we look good though. Everything else is fine, right? So the thing I was a little bit stammering on was like the parentheses, but we're good there. Let's go with this. Okay. All right, next question. So hopefully you all are making your way through these, okay? I'm doing my best to update the gradebook. There is a way where I can link your gradebook grades in Pearson to Blackboard. I haven't figured it out yet though. I was working on it. I was like, oh, this is not as direct as I thought it would be. So I had to like push a little bit more, but we'll get that updated. So, but essentially the grades that you see on Pearson are the grades, give or take. Because actually things are scaled. So just kind of hold tight on that. We'll get that going. Use the graph of this. And I usually, whatever's in the syllabus is probably what I intend on doing, but generally the way it goes is like I'll do, the homework is 10%, classwork is 10%, exams are like total 80%, and the final, that's not right. Something's off. Let me think about it. I think the exams might be 60%, the final might be 20%. That's, I think, so each exam, in this case, because we're only doing 2 exams instead of 3, you know, it does kind of shift it a bit, but the exams I usually do 60%, homework is 10, classwork is 10, and the final I think is 20. All right, that sounds right. That sounds better. But I'll check the syllabus and we'll kind of match it there. Use the graph of this to graph this function. Okay, so basically it's the same function, but now if we say plus 4 on the outside, that's going to move it up by 4. So it's the same function. So if we follow like the center, right? The center should now be at positive 4. The only one that moved up 4 was this one. Okay, let's go on to the next one. Let me check it. Thank you. Okay, so this is F. Now we want to multiply 1/2 on the inside. Okay, so inside manipulations cause a horizontal change, and it's the reverse of our intuition, right? So intuitively, you might think, oh, we multiply by 1/2, it should cause a horizontal shrink by a factor of 1/2, but actually, it causes a horizontal stretch by a factor of 2, right? So it should get wider in a horizontal sense, all right? And by a factor of 2, and I think the only one that does it is D here. Let's go with D. Okay, so it's not trivial, and you wouldn't know it unless you studied it, unless it came across your consciousness, somebody told you, or you saw it in the homework or something like that. Like, to me, that kind of stuff is just not obvious. What I've noticed with like college algebra is kind of like a whole bunch of like simple stuff, but it's so much stuff that is very overwhelming for most people, right? So the concepts are not difficult, but it is like information overload. So the way you combat it, honestly, is through repetition. And so that's why I made like as many of our assignments available as possible. So that way anybody that wanted to get ahead could. You just got to get your reps in, and you got to start early and kind of start hard and like go hard. Yeah, that's the long and short of all of that. Use the graph of this to graph. Okay, so now we're saying we're subtracting 2 on the inside. All right, we're subtracting 2 on the inside. So inside manipulations cause a horizontal change. This should go to the right by 2. So if we follow the center, it should just go to the right by 2. There it is. Why are they all deep? I don't know. I don't know why they're being deep, but they've all been deep. Okay. Let's see what's next. All right, we have several transformations in one, right? So if we can follow the peak here, right? This peak started at what, 1, 3. So this says go right by 1. We're gonna stretch, we're gonna compress, so shrink vertically by a factor of a half, flip it top to bottom. So it should be pointing down. It looks like, then we go up 3. I'm thinking, looks like B is the one that did that behaved properly. Let me think about it. It's either B or C. Yeah, this is the only one that got flipped upside down and went up 3. This one got flipped upside down, but it doesn't look like it went up 3. All right, so I'm gonna go B. Okay. So let me see how many more. Okay, we got 2 more in this section. So let F be a function that associates the employer numbers X of each employee of a corporation with his or her annual salary, F of X in dollars. Suppose each, let me see if I can make this a little bit bigger. Hopefully that's not too jammed. Suppose each employee was awarded an $800 across the board raise and an additional 3% of his or her increased salary. Write a function to describe the new salary. Okay, it says type an expression involving F of X. So let me see. Let F be a function that associates the employee number with his or her annual salary. Suppose each salary is this. Okay, so we have, let's just start with their base salary, right? This is their base salary. They all earned $800 across the board, right? And in addition, so F of X, so the base salary plus $800, and an additional 3% of his or her increased salary. So whatever their salary is, we increased it by 800, and then they threw an additional 3% of the increased salary. So we need 3% of this. So we're going to say 0. If we're increasing by 3%, instead of being at 100%, we're going to be at 103%. So we're going to say 1.03. That's going to increase it by 3% times all of this, right? So if we distribute that 1.03, let's do the following. Hey Siri, what's 1.03 times 800?
1.03 times 800 is 824.
I think this is okay. Let's go with this and see what happens. Okay. So I distributed the 1.03. Okay. We're gonna have to track down some people. Like I'm gonna have to mark some absences and do some starfish reports. I see that pretty clear. All right, let's go like this. It says in the given graph, the temperature, capital T in degrees Fahrenheit of a home is given as a function of time, little t, in hours after midnight over a 24-hour period. At what temperature is the thermostat set during daytime hours? So if this is midnight, that's 6 a.m. Daytime, what is that? 70 degrees Fahrenheit? 70. Okay. Overnight, so throughout the night, if that's 56, 58, 60, so 58 degrees Fahrenheit. That's kind of cold. I mean, if you got some blankets, then you can make it work. The homeowner reprograms the thermostat. Okay, so basically this is saying the temperature minus 9 degrees. So what it's going to do is lower the temperature of all the thing is going to drop the graph by 9 degrees. Man, why are they? Not earlier, it lowers the temperature by 9 degrees, right? Because it's an outside manipulation, so it's going to move it down. Okay. So then the one that moves the temperature down by 9 degrees, if this is 58, it should go down to like 51. Okay. Looks like this one, right? Because if that's 50, this looks like it's a little low. 58 minus 9, yeah, just below 50, so 40, 49, yeah, this is correct. Again, it's D. I don't know what's up with that, but we're gonna go with it. Okay. I'm gonna reprogram. Okay, so now if we say T plus 4, right, that's gonna move the graph to the left 4 units, so that's gonna move it earlier. It's gonna shift it to the left, so it's gonna change. It's gonna move it 4 hours earlier. Move the temperature change 4 hours earlier. That's it. It's gonna move the graph to the left. Okay. And also, I realized, I think yesterday, another one of those classic days, like I think my computer froze or rebooted. And then when I booted everything back up, I think I forgot to hit stream. So that one didn't get recorded. So now there's like a second one that didn't get recorded. I was like, well, damn the breaks. But I mean, again, our lectures are pre-recorded, but these sessions that we have, you know. Anyway, choose the graph that shows, so moves it to the left by 4. What is this? 6, 7, 8, 9, 6, 8, 10, 12. So if that's like 7, so then it should move to like 3 a.m. That little change there. 6 right here, right? I think it's only this one. This is the only one that moved to the left. All right, let's go with this one. This time it's C. Okay. Oh, was that the last one? Okay, that was the last one. So let me see. We get out. So what I'm gonna go ahead and work on the quiz for this week, and we'll do our usual break, and then like for the second part of the week, we'll again just more factoring practice. Like we got work that we can do factoring. So let me kind of open up the quiz, and let's see how well we can do in a little bit of time that we have. Let's go back to assignments. Yeah, let's work on this. Start the test. And then let's hop here. We are going to do here. Must be this one. Yeah, that's right. Okay. All right, so we're going to do the best we can with this, and then I need to do not like that. Here, like this, and new share. It's this one. Share. Okay. All right. Okay, so it's a short quiz. It shouldn't be too terribly bad. Describe the transformations that produce the graph of G and H from the graph of F. Okay, so we started with this. Now, if we multiply the outside by a negative, that's going to flip it top to bottom. So it's going to flip over the x-axis. Okay, H. So H is going to flip it horizontally over the y. Okay. Okay. So hopefully, let me see. I'm gonna click here. So now we have this -2 times x plus 5 squared plus 1. I'm gonna start. This is gonna be a parabola. The base function is a parabola. Click to plot. Okay. If we follow the vertex starting at the origin, this first change says to go left. Go left by 5. So we go left 5, which is put us here. We will stretch vertically by a factor of 2. I'm not going to show that here. We flip it top to bottom because of the negative, and then we go up 1. So then that's going to be the vertex. So then we're going to need a second point. I'm going to just let x be -4. So if x is -4, this is 1. 1 squared is 1 times -2 is -2. Plus 1 is -1. So when x is -4, y is -1. And I think that's all that we need there. Okay, I'm gonna hit save. So again, with the quizzes, we can't see our results until the end. So we're just gonna kind of do it. Okay, let's go into the next one. Whose graph but shifted to the left 9 units, right? Okay. Let's see. So if we're going to the left, we need to do x plus 9 cubed. Okay, I'm gonna go with that. The original function, but then we shifted down by 1, which is this one. Next. Okay. Is there one more? All right. Let's see. This says what? Go right by 2. So we go right 2. Shrink it vertically by a factor of a 3rd. Flip it top to bottom, and then up 4. So it should be squished. I think B is the only one that does that. It goes right 2, up 4, and it's been smushed. Okay, I'm gonna go B. All right. I'm gonna submit. Let's see how do we do. Okay, there you go. Let's go back. I'm just gonna go back and work on something from the past because I know we didn't finish everything. So give me a moment. But that's how quickly the quizzes can go. And again, with these assignments, we get unlimited attempts. So hopefully you're taking advantage of that. Let's see, we just did this one. We could do the quiz from last week. Let's try that one because I see we don't have a score there. Start the test. Okay. Let's hop over here. Let's choose it, which is going to be, yeah, that's the right one. Is it? Huh, how did it choose it? Anyway, let's see if I do full screen. Maybe it didn't. There it is, yeah. Okay. And then, and it looks like it's sharing too. Let's go to share. Let me just make sure that it's sharing. It looks, let's share this one. Share. All right. And let me make sure. Okay, that looks good. So we're just gonna work backwards. I'm just trying to fill in like whatever we haven't done together. I just wanted to kind of touch on it. Find the intervals over which the given function is increasing, decreasing, or constant. So the basic function here is a U-shaped graph. It's a parabola. It's been stretched vertically by a factor of 4 and flipped top to bottom, right? So if we have a U-shaped graph that's upside down, as we trace it left to right, initially it's going to be going up first. So it's going to be increasing from -infinity to 0, and then decreasing from 0 to infinity. All right. Now you can put that in your graphing calculator and look at the graph and get that. I use transformations to get that. It's not constant anywhere. Okay, let's go on to the next one. Okay, decide if it's even, odd, or neither. Okay, so even in this sense, like whenever we have x comma y, we also have negative x comma y. That's like y-axis symmetry. Odd is origin symmetry, so whenever we have x comma y, we also have negative x comma negative y. All right, those are the main two scenarios, right? So let's see. Even, the x's changed, but the y's stay the same. It looks like our y's stayed the same and the x's did change. All right. So the y's are the same, so that should be even. We're gonna go even there. it is kind of like nerve-wracking, like because you can't see the score immediately because you kind of get used to seeing it immediately. Determine algebraically whether the given function is even, odd, or neither. Let me write this one out. This is a good one. Yeah, I think I know the answer, but let me write it out anyway and show what we're doing. Let me go ahead and finish my attendance for today. So I'm gonna just go like this. Oh yeah, I forgot, like our class did change. Anyway, okay, I'm gonna let that be. Okay, let's close this out. I'm gonna go paper, nope. Paper, like this, okay. Now this is just, I'm gonna say it's a review. This is from week 4. 1.4 quiz. Okay, it is important to like have your headers. Also, whatever you see me writing on my tablet, you should have a copy. A copy of everything I've written on the tablet should be available on Blackboard. You should be able to get it. This is question number 3. I'm gonna say even, odd, or neither. Okay. So then we have this f of x, we have 6x to the power 4 plus 7 under, we got this x squared minus 4x, we got f of x, right? Okay. All right, let's hop over to the tablet like this. Make sure it's showing there. Looks good. Okay. I could do that, but I feel like it's gonna be too much. Okay, so even, odd, or neither. Let's do a quick recap. So the definition of a function being even means whenever we evaluate f of negative x, it returns back the original. The definition of a function being odd means whenever we evaluate f of negative x, we get negative of the original. All right, that's the definition of a function being odd. Okay. So for ours, if we want to determine whether it's even, odd, or neither, we need to look at f of negative x. All right. So first I'm gonna, let's do this. We're gonna replace each x with a blank set of parentheses. Okay. 6x to the power 4 plus 7, right? And then x is, again, we're replacing each x with negative x. Okay. So then this gives us x squared plus 4x over 6x to the 4 plus 7. This is not the original, and even if we factor out a negative, we can't get negative of the original either. So this is an example of neither. This one should be neither. Okay. Let me check the time. Okay. So let's hop back over to Pearson. I got neither. Okay. It's funny, we had that question on the temperature. Now it feels like the temperature in here is dropping. Okay, find f of 4. So when x is 4, this says that we need to use line 2. So when x is 4, the output is 5. When x is 5, we use line 1, and the answer is going to be x, which in this case is going to be 5. When x is 6, we use line 1, and the answer is going to be 6. Piecewise function. So when we're to the left of 5, it's a horizontal line through y equals 5. Greater than or equal to 5, it's a diagonal line y equals x. And I think they overlap, filled in. So should be C, right? Oh, I'm trying to see results. Okay. Let me see. I think we got one more. The slope, so average rate of change for our discussion is just slope, right? So basically it's asking us to find the slope. Let me write this one out. So this is question number 5. let me say average rate average rate of change. We have f of x equals 2x. We got x1 equals 0 and x2 equals 4. Okay. So then like this should go away. Okay. So it's basically saying find the slope, right? So we have a set of ordered pairs. When x is 0, the output is 0. When x is 4, the output is 8. All right. So we're just going to basically find the slope between those 2 points. So I like to label them x1, y1, x2, y2. All right. And then the slope formula, or you can call it average rate of change. It's all the same thing. We have it's basically going to be f of x2 minus f of x1 over x2 minus x1. Okay. So that's like our y2, which is what, 8 minus y1, which is 0 over 4 minus 0, which is 2. So the average rate of change is 2. Okay. Let's submit that result. 2. And we're going to submit. So we just did, let's see, how do we do? Oh, it's 90 because it was late. Yeah. So that means we got 100. Okay. So even though we submitted it super late, we still got an A minus. You see what I'm saying? So it's like, and you can do that for any assignment. Okay, let me see the time. Man, we are like cruising through these. And like, I'm trying not to open. I mean, we could go back to old factoring, but I want to at least make sure we've touched on all the stuff from the previous. Let me see. There's some more items that we can do. Let me go. Let me see. We can do. There's another quiz here. This is from week 1. I don't think we ever did that one. Let me start it. And like going back and redoing this stuff is like great prep, you know, because it's a review. Let's go like this. That looks okay. Let me do full screen there. And then we do a new share. And this one. Share. Okay. All right, let me see. I probably won't do the whole time. Like we're supposed to go, I'll probably go to maybe 6:10. Like we'll call it a day. That's like 20 minutes. Because, you know, that's just the nature of everything. Okay, find the distance between these 2 points and then the coordinates of the midpoint. Let me write this one down, as much as I don't want to. So this is going to be, so I'm going to say review. This is week 1. Nope. Week 1. This is a 1.1 quiz. 1.1 quiz. Okay. This is question number 1 from the quiz. I'm going to say find A, the distance, and B, a midpoint. Okay. And we have P is going to be, it looks like it's 8,5, and Q is 8,10. Oh, I was about to do calculations. We don't really have to because over 8 up 5. So these are on the same vertical line. So all we got to do is count the distance between the y's. I was going to use a distance formula, but we don't have to do all that. 10 minus 5 in this case is going to be 5. The answer should be 5. The midpoint average of your x's. So let's see, I'm going to do parentheses. So midpoint is average of the x's, comma average of the y's. So the average of 8 and 8 is 8. The average of 10 and 5 is 7.5. 7.5, right? So just to show you that with the distance formula, the answer should be 5. Let's hop over to the tablet and actually work that out. Okay, so we didn't have to here, but let me just do it. So this will be x1, y1, x2, y2. Distance formula, so the distance between P and Q x2 minus x1 squared plus y2 minus y1 squared. Okay. Okay. Let's see. Okay, so let's plug in what we have. x2 is 8 minus 8 is okay, plus y2 is 10 minus y1 is 5 squared, the square root, right? So this term adds up to 0. Then we have the square root of 25, and that's where the 5 came from. But the only reason I knew that we could count because one of the coordinates were the same, right? They both the x's were 8, so I knew we were on the same vertical line. So then I just counted the difference of the y's because I knew that would work there. Okay, so that's where that came from. Let's hop back over to the quiz. Okay. Graph this, right? So it should be a straight line. This says the y-intercept is 7 and it has a slope of 2. So here, y-intercept is 7, and then if we go up to 9 and right by 1, that's the second point. Okay. X-intercepts, right? X-intercept, if we set y to 0 and solve, we get 4. The y-intercept, if we set x to 0 and solve, we get 6. Okay. I'm just gonna go with that. Normally, I like to write those in ordered pairs, but I think that this wants it in that form. Okay, x-axis symmetry. For x-axis symmetry, we change y to negative y, and if we can get back to the original, then it will be a yes, right? But if we change this to negative y, there's no way to get back to the original, so that's going to be a no. Y-axis symmetry. For y-axis symmetry, we change x to negative x. Notice here, if we change x to negative x, those even exponents cancel out all the negatives, so then we do get back to the original, so this one will be a yes. And then by default, you can't have 2 yeses and 1 no's. Once you get a no, you know, you can't have it be yes to 2 of them and the third one be a no. There's a theorem that says when you're doing the test for symmetry, if any of the if 2 of the 3 are yeses, then you're guaranteed that all 3 are going to be yeses, right? So it can't be the case that the first one is a no, the second one is a yes, and the third one is a yes. So I'm just going to use that theorem to say that this is a no, right? But if I wanted to test for origin, I would change both and see if I can get back to the original. But we wouldn't be able to here, right? So again, there is a theorem for symmetry. Like when you're testing for x-axis, y-axis, and origin symmetry, if any 2 of the 3 are yes, then you're guaranteed that the third one is also a yes, all right? But we got a no and a yes, so then that was enough for me to say, oh, well, the third one has to be a no. Okay, I'm gonna go with that. Okay, equation of a circle. So the center, so we need the center. So then if these are the endpoints of the diameter, then we want the center of the diameter, so we need the midpoint, right? So 5 plus 2 is 7 divided by 2. So it has to be either C or D. And then negative 1 plus 2 is 1 over 2. Okay, so it could still be C or D. And then we need the radius. So we need the distance here. I might write this one out, right? So we need the distance between these 2 points and then cut it in half to find the radius. So let's actually just calculate the distance. So it's either C or D, but let's find the distance. So this is question number 5 from this quiz. We have 5 comma negative 1, and we have 2 comma 2. Okay. I'm gonna hop over to the tablet, and again we're finding the distance formula. So the distance between 2 points is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay. And then this is x1, y1. This is x2, y2. Okay. So then if we plug in, x2 is 2, x1 is 5, y2 is 2, y1 is negative 1. Okay. What is that? 2 minus 5 is negative 3. So negative 3 times negative 3 is a positive 9. 2 plus 1 is 3. Squared is 9. So that's going to be the square root of 18. So that's the diameter. So then the radius is going to be the square root of 18 over 2. We could take it further. Stop. So when we go to plug it into our formula, it's going to be r squared. So let me just go ahead and find r squared. So r squared is going to be 18 over 4, 9 over 2. Okay. So the 9 over 2 is what we're looking for. So then it should be C. All right, we're going to go with it. See what it's looking like. Okay, I think we got those correct. Okay. Let's see what else we got. So I think we went back and did all the quizzes. Is there a way I can just show the scores? Let me see. That's fine. That's good. We just did that one. So so basically what I'm doing, I'm looking at the grades. Anything that's not an A, either a 90 or 100, like this one. We didn't finish that one. Okay, we can work on this one. Let's see, where did we leave off? Improve the score. Yeah, let's improve it. Okay, that's fine. So I got a notification that there's going to be a late penalty for late submissions. Okay, I'm going to open this up. So since we have a lot of extra time, you can go back and improve scores. So it's kind of interesting because I get a sense of what you guys experience on your end, even though I know it's a lot more thought process for you guys, which it should be. Let's go like this, properties. This one, right, factoring. Okay. Then we're gonna make it full screen. It should be showing there. And we're gonna share, new share. So we'll hang out for like another 10 minutes or so. This one and this one, share. Okay. Oh, uh-oh, did I do the wrong one? Okay, let me make sure the right thing is showing. Okay. All right. So we're asked to factor the trinomial. Oh, factoring, yes. Okay, so this was the result there. I'm just gonna take some notes. Style, okay. Now this is, so I'm gonna say review. This comes from week 2, day 8, factoring trinomials. Okay, factoring trinomials. This is question number 14. We're asked to factor. We have this negative 15x squared minus 21x plus 18. Okay, I'm gonna hop over here. All right, so right off the rip, the first thing that comes to my mind when factoring in general, you ask yourself, is there a greatest common factor, right? It does look like at least 3, right? Let's factor out negative 3. So this is going to be equal to, we can factor out negative 3. What does that leave us with? The first one leaves us with 5x squared plus 7x minus, what is that, 6? Negative 3 times 5 is negative 15. Negative 3 times 7 is negative 21. Negative 3 times negative 6 is positive 18. Okay? Yeah, I know. Yeah, I know. Okay. Okay. So now here, we're looking for two numbers that multiply to give us, hopefully you did not say negative 6. Two numbers that multiply to give us negative 30. A times C, right? We got to say the 5 times the 6 give us negative 30. So we're looking for two numbers that multiply to give us negative 30 and to add up to 7. Negative 30 is what, 5 times 6? So that's going to be 2 times 3 times 5. So what I'm going to do, I'm going to go through all the factors of negative 30 and stop at the line that adds up to 7. So first we have negative 1 and 30, but that adds up to 29, so those are not the 2. Now we have negative 2. If we use this negative 2, then we have 15 left over. That adds up to 13. We're almost there, but these are not the two numbers we're looking for. We can do negative 3. If we use this negative 3, we got 10 left over. And that adds up to 7. These are the two numbers that we were looking for. Okay. So then I'm going to use a technique, I like to call it the box method for factoring this. Okay. In the upper left hand corner goes a leading term, that's 5x squared. The lower right is the constant, which is negative 6. And then what we're going to do, we're going to rewrite this 7x using the two numbers that we just found. So that green 7x, we're going to rewrite it using the two numbers we just found. So we got a negative 3x and we got a positive 10x, right? So I just got a notification from Tabitha Brown. She says, fried peanut butter and jelly sandwiches will change your life. I'm like, you know, now that I think about it, she might be onto something. Because I actually did used to do fried peanut butter sandwiches. Those were actually okay. Okay. So now let's keep going. So here, what do the top two have in common? Looks like the only thing they have in common is x. What do the bottom two have in common? 2. So we can factor out a 2 from both of those, a plus 2. What do the left two have in common? They both have 5x. So we can factor out a 5x. And what do the two on the right have in common? We can factor out a negative 3. So then the claim is that, let me get a copy. Copy. Is that this now factors into 5x minus 3 times, and I need to keep, I'll keep that. This just comes down. And we have x plus 2. Okay. And then we just do we just multiply back to do a quick check. Notice that 5x times x is x squared. 5x times 2 is 10. Minus 7 is, sorry, 10 minus 3 is 7, so that checks out. Negative 3, here, let's do this. Negative 3 times 2 is negative 6. All right, so it checks out. Okay. And I think that's it. That's the fully factored form of the original. There are no other common factors. Nothing else can be factored further. Okay. All right. Let me see. Is this a quiz? I think this is a quiz. Let's submit this result. Oh, this way. Oh, it's not a quiz. Okay. Well, we can save some for next time. All right. Let's see. So we got a result of negative 3 times 5x 5x minus 3 times x plus 2. Okay. All right. let's see the next one. This one has a lot going on. Probably do 3 from everything. Okay, let me see if I can do it. So we get this 3. I think all the coefficients we can factor out of 3. The smallest exponent on x is going to be x squared. So they all have at least 2 x's, and it looks like the smallest exponent on y is y squared. So we can factor out a 3x squared y squared from all the terms. So from the first one, what's going to be left is x squared minus, let me see, that's a 3, 18 is 6. It's going to be, we took away 2 x's, so x is left over and a y is left over. Now it's probably going to be more that we can do here. I'm just kind of seeing what I can do. We get 3, 2, 4, y squared. Okay, y squared. Let's see. Looks like, is that a perfect square? Let me see. 2, what would that be? 15, 16, 17, 18, 15, 16, 17, 18. 2 times this times this. So 9? No. 18? 20 times 20 is 400. It could be 18. 8 times 8. 64. Okay. Hey Siri, what's 18 squared?
18 raised to the second power is 324.
Okay. So this is like a perfect square trinomial. Looks like it's going to be 18. Because that's 18y squared. It looks like x, let me think about it. X minus 18y quantity squared, I think that's what that factors into. Let me think about it. Both the same, yeah, x. So that looks like I could factor further to x minus 18y quantity squared. It looks like a perfect square trinomial, right? I think this is it. All right, let's check this one. That was fun. Okay. So that takes me to where I wanted to get to for today. So let me do something really quickly. Let me go paper. I'm just going to share my notes. I'm going to hit share. I want to send it to Box. And I'm going to send a copy that you can access on Blackboard on the spring. Here, notes. And there is fine. So I'm going to export there, send to Box. Okay. I think it's sent. It should have sent. Okay. And then let me hop back over here and do like this. No, it's fine. Okay, that looks okay. Okay, so I can't think of any other major announcements. So if there aren't any burning questions, we're actually going to end the session here, okay? And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.